Continuing on with integration, we have our definite integrals in the fundamental theorem of calculus. So the integral from a to b of our function dx is equal to the antiderivative of our function, and then we plug in our bounds. We plug in our top bound, and then we plug in our lower bound, and then we subtract the 2. So if I have this function, the integral from 0 to 8 of x to the 1/3 minus x to the 2/3 dx, I need to take the antiderivative, then plug in 8, plug in 0, and subtract the 2. What's the antiderivative of x to the 1/3? X to the what? 4/3. What is the antiderivative of x to the 2/3?
3/5 to x to the 5/3.
And then I'm going to evaluate that from 8 to 0. Remember, we always plug in our top bound and subtract it from when we plug in our lower bound. Be careful when you subtract, because you're subtracting that entire second part when you plug in the lower bound. So if it was something other than 0, you want to make sure to carry over this negative right here. Luckily for us, it is just 0, so everything goes away on that back end. Let's review. 8 to the 4/3 can be written how? Exactly. The denominator of your exponent is the root. The numerator stays on the inside with the base, and it's easier to apply the root and then the power. So what's the cube root of 8? 2 to the 4th. So that means I'm going to do 3/4 of 16. Use your trick. How many times does 4 go into 16?
4.
And what's 3 times 4?
12.
And that is what this is. 8 to the 5/3, what root is it? And I already know the cube root of 8 is 2, so what's 2 to the 5th power? Unfortunately, 32 is not divisible by 5, so we're just going to multiply with 32 times 3.
96.
So this becomes 96 over 5. 12 can be written as what over 5?
16.
So then I subtracted from 96 fifths. So my answer is negative 36 fifths. Question? That's exactly what it means. It means that since the area is negative, that means it went underneath the x-axis. Very good. Questions? Let's take a look at this. Given the integral from 0 to 2 of f of x dx is equal to 8, I don't have a function here. So now I got to rely on those different properties from before. Find the value of the integral from 0 to 2 of 3 f of x dx. What would that be?
24.
24. Because remember, I can pull out that constant, and then I'm able to replace this entire expression with 8. So then this just turns into 3 times 8, which is 24. Part B asks me to find the value of the integral from 0 to 2 of f of x plus x squared. This is a tad bit different because I actually have a term here, an expression. So I want to apply my rules. Split up the 2. And again, I know that this entire piece right here is going to become 8. But what do I have to do with the second integral? I got to integrate and then plug and bounce. Online, what's the antiderivative of x squared?
1/3 x cubed.
Very good. And I'm going to evaluate that from 0 to 2. Which bound goes in first? 2. So that becomes 1/3 2 cubed minus 1/3 0 cubed. Of course, again, this goes away. 2 cubed is
8.
So this becomes 8 over 3. So I have 8 plus 8 over 3. This 8 came from before. And what's 8 plus 8/3?
32.
So then that would be my area or the value of that integral. Common for IB to do something like this because students tend to forget that you actually have to integrate that back half and then add it. Okay, this one's on you. Find the value of K, knowing this information. What's K? $12? How'd you get 12? Oh, it's a 2. That very much so. That was definitely not. That's a 2. Go ahead, go ahead. Antiderivative of 1 over x is ln of x. Evaluate it. Should equal the ln of 6. Yes, the ln of k minus the ln of 2 becomes that fraction. Don't forget your laws of logarithms that says that you can combine subtraction or you can condense subtraction with division. Then I can say k over 2 equal to 6. So k is 12. Trying this one on your own. Let's get a little bit of trig work in there. First off, what is the antiderivative of cosine 2/3 x? Three over 2 sine 2/3 x. Okay. Yes, remember, this is one of those where you it's your linear factor, so it's 1 over a sine ax plus b. Okay. 2/3 is a, so that's how we get 3 over 2. We evaluate that from 0 to pi over 2. Of course, you need to know your unit circle anytime you're dealing with trig stuff. So when you plug in pi over 2, you would have had pi over 3 that you're taking the sine of, then minus 3 over 2 sine of 0. What is the sine of pi over 3? Root 3 over 2, so this turns into 3 root 3 over 4, and then this was the sine of 0. So my answer is just root 3 root 3 over 4. Okay, do another one. So somebody online, what is the antiderivative of 2 sine x plus sine 2x?
-2 cosine x minus 1/2 cosine 2x.
Very good. I'm going to evaluate that from 0 to pi. So I'm going to plug in pi first. Then I'm going to subtract the entire expression when I plug in 0. You definitely want to be careful because what's the cosine of 0? 1. What's the cosine of pi?
-1.
So this turns into a 2 minus, what's the cosine of 2 pi?
1.
So this becomes a 1/2 minus, in parentheses, I know cosine of 0 is 1, so this becomes a -2. And then this becomes a minus 1/2. That's a minuses. Careful. But distribute over that negative, I'll have 2 minus 1/2 plus 2 plus 1/2. Did you get 4? How are we with the fundamental theorem of calculus? So far, so good? Good stuff. Let's do this one. Let's do this one. That is a square. That's a t. Online, how am I gonna take the antiderivative of this expression?
The substitution method.
Then we gotta use substitution. I need to make u what?
2t squared minus 3t minus 2.
Which means that the derivative of it will be
4t minus 3.
very good. But if you look, the numerator is not 4t minus 3, it's 8t minus 6. So I got times it by 2. So when I do the antiderivative, it's going to be 2 du over u, which is the same thing as saying 2 over u du. What's the antiderivative of 2 over u? To ln of u. But I don't put u, I put the actual expression back in. Now I'm not done, but I just want to make sure we're good for that on u substitution. Now I need to actually apply the bounds, okay? So this becomes 2 ln. When I plug in 4 squared is times 2. Okay, so I'll have 32 minus 3 times 4 minus 2. Then I subtract that from when I plug in 3. What's 3 squared times 2? 3 times 3. Okay. This becomes 2 ln of, what's that?
18.
And then this one becomes 7. How do I simplify that?
Divide the element.
I can't divide the ln's yet. I have to do something before I can divide them.
Factor out the 2.
I can factor out the 2. Now I can divide them. So essentially, I can't have any coefficient in front of my ln's in order for me to divide. So if I factor that out, that'll give me the ln of 18 over 7.
Could you also have made the 2 an exponent on each of them?
I could have made the 2 the exponent. And then I know that 7 squared is 49. And what's 18 squared? You might know? Quick. 324. Yeah. That's the fundamental theorem of calculus, mixed in with a little bit of reviews from last time when we talked about integration. Let's move forward and let's talk about some of the application parts of integration, such as area between two curves. You do not have to write this part down, okay? It's just the definition, literally a copy and paste from the notes when we did integration at the beginning of the year, okay? But essentially, if you have two curves, to find the area between them, you take the top curve and then subtract it from the bottom curve, from one bound to the other bound. And that's how you find the area between your two curves. Okay? Because without it, you're essentially just finding the area between the curve and the x-axis. But if you're trying to limit it between two curves, then you do the top curve, which will be y1, minus the bottom curve. So top curve, bottom curve, or F and G, and then you evaluate the bounds. It's important to know which curve's on top. You may have to resort to old school graphing of linear equations, quadratic equations, or using your calculator as well. Linear motion also is part of integration. Remember, that's displacement, velocity, acceleration. We know that if I go forward that is the derivative, but if I have acceleration, I can find velocity by doing the antiderivative, and I can find displacement by doing the antiderivative of velocity. Displacement tells us the distance and direction of a particle. We know that from integration. The integral, though, tells us the change in displacement from time 1 to time 2. So again, essentially taking the antiderivative velocity, plugging in my bounds and finding the difference between the two to find the change in displacement. All right, so then yes, plug in your upper bound, subtract from when you plug in your lower bound, you can find the change in displacement, okay? Remember, when you see rate of change or change in something, especially when it deals with your particle movement and things like that, you're dealing with calculus, okay? You have to remember derivatives, integration, things of that nature. Also, don't forget distance traveled was also found by doing the antiderivative. When you took the absolute value of velocity, aka speed, you did find your total distance traveled between time 1 and time 2, or A and B. This is in your reference booklet. So again, you just take the antiderivative from A to B of the absolute value of velocity. This is done in your calculator. This cannot be done by hand unless you're given an actual graph of the function, and then you'll essentially find the area underneath the curve to find the total distance traveled, okay? All right, so let's take a look at a few problems. We're gonna find the x-intercepts of this function, x to the 4th minus x squared. Let's get down what's important. If you want to write down all the parts of the question, you can always go back and watch the video. How do I find x-intercepts of any function? Set it equal to 0. So x to the 4th minus x squared equals 0. How do I solve that? I would factor out an x squared. Don't forget. And then set both equal to 0. What are my x-intercepts?
X equals 0.
0, 1, and -1. Don't forget here, when you add 1 to the other side and take the square root, it's always plus or minus that value. I can do the same thing for 0, plus or minus 0 is just 0. So my x-intercepts are 0, 0, 1, 0, and -1, 0. Don't forget about that. Remember, you got to know a few things of prior knowledge in order to be able to do things with integration and differentiation. Especially with some of these integration problems that ask us to do things like this. You know, they go together. Calculus is together, so you can't forget certain things, because I can't just do a test that's just straight integration. It's not possible. There's going to be a derivative in there somewhere. So what is f prime of x? 4x cubed minus 2x. Remember, with derivatives, you bring the exponent down and then you subtract 1 from your exponent. How do I find the coordinates of the maximum and minimum? Still derivative. Set what equal to 0? I do set the derivative equal to 0 because remember, wherever the derivative or the tangent line has a gradient of 0, that means we have a maximum or minimum. So again, I'm going to factor out a 2x squared, a 2x GCF. That leaves me with 2x squared minus 1 equals 0. Set them both equal to 0. So that'd be 2x equals 0 and 2x squared minus 1 equals 0. So then I have x equals 0. And then what would this be?
Plus or minus the square root of 1/2.
It's gonna be plus or minus the square root of 1/2, which is root 2 over 2. Now those are just the x values. Need to figure out which one's the maximum and the minimum. I'll put it on my number line. I have 0, root 2 over 2, negative root 2 over 2. If you're curious to try to be like, well, what numbers in between 0 and root 2 over 2? Use your unit circle. What value is in between 0 and root 2 over 2? 1/2. Okay. I'll plug in some test points into the derivative to see if it's going to be positive or negative. That will help me in my next part, which is asking me to sketch the graph of f. And it will also tell me where exactly there are minimums and maximums. So we pick our test points. They can be anything less than negative root 2 over 2, such like -1, anything in between the two, and anything greater than root 2 over 2. What were the symbols? Going from left to right. Negative, positive, negative, positive. Remember, you're plugging your test points into the derivative to see if it's increasing or decreasing. If I go from negative to positive, that means we have a what?
Minimum.
A minimum. So we actually have a minimum at negative root 2 over 2 and positive root 2 over 2. And then at 0, we have a what? We have a maximum because it goes from positive to negative. So now we just have to find the y coordinates. How do I find the y coordinates when I'm given the x coordinates?
Plug into the original.
I plug them into the original. When I plug in negative root 2 over 2, or even positive root 2 over 2 into the original, what do I get? A negative 1/4. And when I plug in 0, so there are my coordinates. This helps me be able to graph in part C. I have x-intercepts at 0, 0, -1, 0, and 1, 0. I have a maximum at 0, 0, which is also an x-intercept. I have a minimum at negative root 2 over 2, negative 1/2, and also at positive root 2 over 2, and sorry, negative 1/4. I am decreasing from negative infinity to negative root 2 over 2. I'm increasing from root 2 over 2 to 0. I'm decreasing from 0 to root 2 over 2. Then I'm increasing everywhere else. I also have minimums at those points, which I've indicated here. So this is what our graph looks like. F does. Did everybody catch that? Try to do it slowly. What does 1 minus x squared look like? What does 1 minus x squared look like? This is old. Vertex is at 0, 1. It looks like a what?
A downward U.
A downward U. How do you know it opens down?
Because that is negative.
Because I have a negative leading coefficient there. I do have a y-intercept at 0, 1, and it should look like a parabola that opens down. Where does it intersect with my graph of f? At 1 and negative 1. How do you know that? Well, you can always plug in points, okay? But you can also remember your pattern. Normally it's up 1 over 1, up 3 over 1. Well, it's flipped over, so it's down 1 over 1. And there you have g of x. You're writing down the expression that gives the area of the region between F and G, and then you're actually finding that region. As you can see, there are your two curves. There's the area in between them. Which curve goes on top? G of X, which was 1 minus X squared. Then I subtract that from F of X, which was X to the 4th minus X squared. I'm going to be very cautious because since I am subtracting, I need to make sure I include my parentheses. What are my bounds? -1 to 1. So a more simplified expression would be negative X to the 4th plus 1, right? Because my X squares cancel out. Find the antiderivative, find my area between the two curves. So go ahead and work this out. What's the antiderivative of negative X to the 4th plus 1? And so we're going to evaluate that from -1 to 1, but I plug in my upper bound first. Luckily, these are just 1s, so it's actually kind of nice. Then subtract it from when I plug in my lower bound, remembering that any negative number raised to a odd root is going to be negative. So this expression becomes 4/5 minus, this one over here becomes a negative 4/5. Two negatives make a, and so my final answer is 8/5. Feeling good. All right. One of the things, if you guys were hearing the conversation between Bodie and I, you don't have to worry about the curve dipping below the x-axis when you're trying to find the area between two curves, unless one curve becomes the top function and the other one becomes the bottom. So take a look at this. We're not going to do this one all the way out, but we essentially have three curves here. We have G, F, and H. G is negative x squared, which is this one right here. H of x is the line because it's 2x minus 4. And then f of x is this quadratic 1/4 x squared, which is the one that opens up. So of course, you find the coordinates of Q because you want to figure out where those two intersect each other. And then you also show that the line passes through P and Q as well, okay? You find the coordinates of P corrected for significant figures. So this one would have been a calculator problem, but what I'm concerned about is writing down the expression for the area of the shaded region. The shaded region is the part here in between all of those. Now, when you look at this, there's points when one curves on the top and one curves on the bottom, but then there's another point where it's not the same two curves. Can everybody see that in that diagram? I have the quadratic. And then I have the line. Can everybody see? Well, first off, they intersect here at 0. So from 0 and moving to the right, which curve is on the top? F of x. So you'll do f of x minus g of x. But then there's a point, is g always on the bottom? For this entire shaded region, which is here. No. At this point, which one is on the top and which one's on the bottom? Exactly. So this is when you would actually have to split up the integral. And that's why in part BI, I asked you to find the value of P, which is this point right here, because from 0 to P, F's on the top and G's on the bottom. But then from P until Q, F's on the top and H is on the bottom. So this would be a very generalized expression to find the area between those two curves. This is when you actually would have to split it up if it ever comes to a point in that shaded region where one curve is no longer on the top or the bottom and they've switched or something. And of course, you will want to actually plug in what f of x is, what g of x is, and find p and q, but this would be that general expression. Does that make sense? Remember to find total distance traveled. Of course, it's just the absolute value of velocity, but here's an example where you're not given a function for velocity, you're just given an actual graph. So to find the total distance traveled from 0 to 16, we would actually have to find what? Those three shades. I have to find the area of this, the area of this, and the area of this. The only thing is that since I'm talking about total distance traveled, all of my areas need to be positive. So even though they do go below the x-axis for two of those three regions, I'm talking about total distance traveled. So I would do the absolute value of whatever those two negative areas would be and then add them up. And then that will give me my total distance traveled. Okay. But look at this, it says the area of the curve, y equals cosine x between 0 and k. So the area underneath the curve implies the integral between 0 and k of our function is 0.942. What does is in math mean? Equals. A lot of students tend to forget that, especially when it comes to the SAT and ACT. Is means equals. It sets up your equations. K has to be in between 0 and pi over 2. How do I figure this out?
You say that the normal thing to find the area, but then you factor over the other ones. So you say
Say the integral of cosine x, which is,
I think it's just
I think so too. Evaluated from technically 0 to k, but I know what you mean. So this becomes sine k minus sine of 0, which equals 0.942. What's the sine of 0? So it's really just sine k is equal to 0.942. How do I find an angle? I do the inverse. So again, there's a lot of prior knowledge things that you guys need to know in order to be able to do this. But more specifically as well, clearly this would be a calculator question. What question do you think I'm going to ask you before I ask for the answer?
What degree is your calculator in?
Yes. Not degree, but what mode? Yes.
Yeah, sorry.
Am I in degree or do I need to be in radian mode when I do the inverse? What tells you that it should be in radian?
the answer. It
But-
just looks weird than actually.
Besides the answer, the range right here.
Oh.
It's in radian, so you want to make sure that you are in radian, okay? So realize that when you guys sit for your exam, your calculator is going to be reset. Luckily for you, you guys do deal with radians, so it is going to already be in radian mode when you start working on a problem. However, when we do trigonometry, right triangles, non-right triangles, you'll need to be in degree mode to do law of sines and law of cosines. So you'll have to remember to switch back to degree mode for those problems. However, majority of it will probably be in radian. And so you'll want to make sure that your calculator is in radian. Not only that, your stat diagnostic will be off, so you'll have to turn it on. And of course, we'll go over that as we continue to review. real quick. There is a way to do integration on your calculator, which would be helpful, not necessarily for this problem, but that last problem where we set up that general expression to find the area. We just didn't actually work it out. In your calculator, as mine is being pulled up, I think everybody had the updated version of our calculator. So in our home screen, we wanted to go to math, and then we wanted to go down to option 9, okay? Because option 9 is what pulled up the integral feature, and then we just type in our lower bound. So let's say if we wanted to go from -1 to 1, and our function was negative x to the 4th plus 1, or plus x, because I think that's what it was for the last problem. We just want to make sure we plug in that dx, and then we'll get our answer. Oh, it's to the 5th. It was 1/5 x to the 5th. That's what it was. It was -1/5 x to the 5th. So of course, but that's how we would do it. So math 9 takes us to that integral feature. Does anybody not have that?